They were launched in 1977. That's a long time ago. We say 41 years, but it's really two generations ago.
Voyager 2 was the one that was chosen to do the grand tour. That is to fly by Jupiter, and then Saturn, and then Uranus, and then Neptune.
In the 1970s, NASA sent 2 probes into the dark, emptied space to unlock interstellar space's never-disclosed mysteries and all the planetary objects. Voyager 1 and its sister Voyager 2 were the 2 probes sent on this mission to study the outer solar system, particularly Jupiter and Saturn. But later, the planets were extended to Uranus and Neptune as well. It was the most advanced spacecraft of that time, equipped with the latest technologies to capture images and collect scientific data about these distant gas giants, their moons, rings, and much more. However, Voyager 1 has now crossed the heliopause to reach interstellar space, where it has encountered some strange forces that have shocked NASA and the entire space industry. So the question is, what's that in deep space? Is this a force controlling outer space? Let's delve deeper into what Voyager 1 is, its grand tour, the crossing of heliospace, and making contact with that unknown force. On the 5th of September 1977, NASA launched its Voyager program to study interstellar space beyond the Sun's heliosphere. After unveiling its sister probe, Voyager 2, Voyager 1 debuted to explore the space system, including planets like Jupiter, Saturn, Neptune, and Uranus. It was set on a space mission from Cape Canaveral, Florida, aboard a Titan IIIe Centaur launch vehicle. As we have already discussed, the modern technology in this robotic spacecraft made it exceptional enough to set everyone's expectations high. The NASA astrophysicists were damn sure that Voyager 1 would cross the heliosphere and collect exciting data about the interstellar cosmos. Since the day it started exploring the solar system, Voyager 1 has achieved enormous success in finding out the locked secrets of planets. It first reached Jupiter in 1979 and made several important discoveries. Voyager 1 discovered the Great Red Spot, which was a massive storm on the surface of Jupiter, and provided its detailed images and data. It also astonished the scientist by discovering the first volcanic activities on one of Jupiter's moons, low beyond the Earth's surface. In 1980, Voyager 1 encountered Saturn, again opening a huge chapter of hypotheses for astrophysicists. The spacecraft revealed shocking, intricate details about Saturn's stunning ring system, structure, and division. It also discovered a thick atmosphere on Saturn's largest moon, Titan, covered with orange hues, which further intrigued the scientist to study more about this moon. All these discoveries Voyager 1 made created a booming fuss at NASA's headquarters, enabling them to discover more and more. Not only this, but Voyager 1 also made photographers shocked to the core with breathtaking images of the planet's atmosphere as it came close to it for 77,000 miles. After the exploration of Saturn was completed in November 1980, Voyager 1 was set on another exciting voyage to discover the hidden mysteries of Uranus. It basically conducted a flyby to Uranus, coming within 50,600 miles of the planet's cloud tops. Voyager 1 found that Uranus rotates almost sideways compared to other planets, which get named the dramatically titled rotation. It also uncovered the facts of some new moons and the fainted ring around Uranus. On August 25, 1989, this robotic spacecraft also encountered Neptune very closely, coming within 3,000 miles of the planet's cloud tops. This contact again resulted in several more discoveries about such giant planets. Voyager 1 made a discovery about the massive dark storm in Neptune's atmosphere, similar to Jupiter's Great Red Spot, but with a shorter lifespan. It also observed active geysers, the largest moon of Neptune, ejecting nitrogen particles into space. After ending this brief exploration of solar planets, Voyager 1 went on another unprecedented journey outside the solar system. It crossed the region known as termination shock, further embarking the spacecraft's journey of entering into a turbulent region of space in December 2004 at a distance of about 8.7 billion miles from Earth. Within the termination shock was a heliosheath, a vast and baldy silent space where the winds are compressed and form a bubble around the space system known as the heliosphere. From the brief journey to planets and termination shock, and then to the heliosphere, the trajectory of Voyager 1 was certainly complex, but it was worth waiting for. As of the 25th of August 2012, after 35 years of its launch, Voyager 1 successfully crossed the heliopause, the boundary of interstellar space, and became the first human-made object to enter the interstellar medium. After landing outside space, the Voyager 1 became a true interstellar probe that aimed to send crucial data and phenomenal images of the solar system and heliospheric back to the Earth's surface. Firstly, it was on a mission to discover high-energy cosmic rays from the Milky Way galaxy. Those cosmic rays emerged as charged particles accelerated with astronomical processes, which further helped the scientists understand the Milky Way galaxy's complex structure. This robotic spacecraft also helped understand the directions of the magnetic field in the interstellar medium to study its dynamics and interactions with the heliosphere. As Voyager 1 went deeper into the interstellar medium, it sent important information regarding the solar wind's properties and the heliosphere's shape and size. With the help of these data and the heliosphere's edges, scientists were able to figure out Voyager 1's evolution over time. Voyager 1's incredible distance to Earth made it the farthest human-made space probe from the Earth's surface ever launched in history. Its sister probe, Voyager 2, launched before Voyager 1 but hasn't traveled this far, following a different trajectory to taking on tours of outer planets. However, with such overwhelming distance, maintaining a smooth communication system has also become a hurdle. The scientists have deployed a network of large antennas around the globe, connecting the space probe with Earth through NASA's Deep Space Network, DSN. But still, it takes over 20 hours for a single person to reach Earth from Voyager 1. In 2012, when the arrival of Voyager 1 in interstellar space was marked a historic landing, some scientists were skeptical that it had truly reached the interstellar medium or went to an unknown space. But fortunately, in 2013, they eventually concluded that it had indeed crossed into the interstellar medium by observing plasma oscillations triggered by a solar outburst in March 2012. These oscillations strongly supported the evidence because Voyager 1's plasma oscillators stopped working in 1980. Even in 2013, astrophysicists sent audio signals from these plasma signals, making it the first ever sound listened to on the interstellar medium. This groundbreaking achievement for the scientific community helped them further understand the environment beyond the solar system. But it's worth noticing that Voyager, the 1st of May, have left the solar system. It has not yet reached the outermost zone, called the Oort cloud, and still has a long way to go before it comes to its boundary. However, in October 2020, some strange thing occurred with Voyager 1. Scientists observed an unexpected increase in density in space beyond the solar system, and not only Voyager 1, but also Voyager 2 detected this increase. In 2021, NASA observed increasing measurements of material density in interstellar space for the first time. They also discovered hovering interstellar space sound, igniting their urge to discover more. The plasma interaction indicated the presence of radiomagnetic rays, but their origin and nature remained elusive. These rays completely differed from the common cosmic rays that emerged from astrophysical sources like supernovas. They interact with plasma and cause fluctuations that create distinctive patterns in the data received by Voyager 1's instruments, allowing scientists to identify and study them. One theory says that these radiomagnetic rays potentially radiate from solar origin, where the sun's magnetic field interacts with the interstellar medium. On the contrary, another theory says these rays might have originated from distant interstellar sources and have relations with cosmic rays. They are high-energy particles from various astrophysical phenomena, like supernova explosions or active galactic nuclei. They are likely to interact with the interstellar medium, which leads to observing magnetic field fluctuations. Despite these two theories regarding those mysterious EM waves, another third theory says about the influence of the Milky Way magnetic field on the radiomagnetic rays. Because Voyager 1 goes more profoundly into the interstellar medium, it encounters different regions of this magnetic field. These variations might play a role in shaping the properties of the observed radiomagnetic rays. But unfortunately, despite all these hypotheses, scientists are unable to solve the mystery of these radiomagnetic rays yet. They continue to analyze the received data from Voyager 1 to reveal this enigma. The detection of these rays shows the importance of continued exploration and the knowledge that Voyager 1 continues to provide as it embarks on its historic journey into the interstellar cosmos. I hope you enjoyed this video. Make sure to subscribe to our channel and let us know if you enjoy such fascinating space stories.